Today I'm going to teach you some tricks in superposition principle in electrostatics. Suppose you want to solve some difficult problems like if all the charges are in x, y and z plane, that's in three-dimensional distributed, then how to find a force on any one charge. So what you have to do is, first trick is place the charge at origin on which you want to find force. Okay. Second trick is write coordinates of each charges. Third, if the force is attractive, use positive sign. If the force is repulsive, use negative sign. See, take an example. Suppose there are 5 charges are given, 2 microcoulomb, 3 microcoulomb, minus 4 microcoulomb and 1 microcoulomb at the corners of a rectangle of size 2 meter by 1 meter. There is one more charge of 5 microcoulomb charge which is placed perpendicularly at a distance of 1 meter from the center of the rectangle, perpendicularly away from the center of the rectangle. Say we want to find force acting on 5 microcoulomb charge. You can see if 2, 3, minus 4 and 1, if these 4 charges are in xy plane, then the 5 microcoulomb charge is going to be in x, y and z plane. So how to write the force acting on 5 microcoulomb charge? What you have to do is, you have to place this 5 microcoulomb charge at the origin. Then you have to write down the coordinates of each charges. Okay, so let's see. I want to find the force acting on 5 microcoulomb charge. How we do it? Say, make a rectangle. Say this is 2 meter by 1 meter. Here is 2 microcoulomb charge. Here is 3 microcoulomb charge. Here is minus 4 microcoulomb charge. And here is 1 microcoulomb charge. So this 5 microcoulomb charge will be somewhat here. This is the 5 microcoulomb charge. So let's say this is my x-axis. Say this is my y-axis, and out of the plane sheet, this is my z-axis. So now imagine this is 2 meter by 1 meter rectangle, and from center of this rectangle perpendicularly downside there is a charge of 5 microcoulomb charge. Okay, this I'm considering x-axis, this is y-axis and this is z-axis. Now let's try to write the coordinates of all these charges. Of course, this 3 microcoulomb charge, the x coordinate will be 1. So definitely x coordinate of minus 2 microcoulomb charge will be minus 1 because it's a 2 meter length. So it's 1, then this is going to be minus 1. The same way, this would be 1. So this would be minus 1. Now y coordinate, because height from origin to all these 4 points will be what? Y coordinate, this will be 1, 1, 1 and 1. Now z coordinate, which is out of this sheet, that means is going to be half forward in upward direction. So half will be in the backward, that means it will be minus half. This would be half, so this would be minus half. That much you have to do in this question. If you write down the coordinates carefully, then question will be solved just in one line. See, I'm writing the force, the net force acting on 5 microcoulomb charge. Here, the 1 over 4 pi of epsilon naught would be common. Macro into micro product, that comes out to be minus 12, will be common. Now, force between 5 and 3, it would be 5 into 3. That's a q1, q2. Because these two are the positive, then force would be what? Repulsive. Then I'm using negative sign. The distance from 5 microcoulomb charge to 3 microcoulomb charge, because this point is what? It's a origin. So you can write this vector, r vector, that vector to be equals to how much? It's a I cap plus j cap plus k cap upon 2, which magnitude, that means the distance from the origin to this corner, would be square root of 1 plus 1 plus 1 by 4, which is 2 plus 1 by 4, which is 819 by 4, which comes out to be 3 by 2 meter. So it's a q1 q2 upon 3 by 2 whole square. Now here we have to write the direction. And how we write the direction? By the unit vector. And how we write the unit vector? As we know, the unit vector to be equals to is the vector upon its magnitude. So it would be I cap plus j cap plus k cap upon 2 upon root 2 upon 3 by 2. Now the same way we can write the force from between 5 and minus 4 microcoulomb, because it's a 5 and minus 4. This force will be attractive, so we'll use plus sign. 5 into 4 upon distance, it would be the same, 3 by 2 square. The unit vector would be, it's I cap plus j cap minus k cap upon 2 upon 3 by 2. Now, force between 5 microcoulomb charge and 2 microcoulomb charge, it would be, it's 5 into 2, because 5 plus, this is also plus, this force is going to be repulsive. We'll use the negative sign upon 3 by 2 whole square. The unit vector would be minus I cap plus j cap plus k cap upon 2 upon 3 by 2. Now, the force between 5 microcoulomb charge and 1 microcoulomb charge, because both are positive, the force is going to be the repulsive. We use the negative sign. It's a 5 into 1 upon 3 by 2 whole square. It's a minus I cap plus j cap minus k cap upon 2 upon 3 by 2. So you can see I have written the total force in one line. The next thing what you have to do is collect the coefficient of I cap and j cap and k cap, and then you can find easily the net force in vector form, I cap and j cap and k cap. The same way you can also get the magnitude of the force. Now take another example. Suppose it's given a cube of side A. You have given a cube of side A. Point charges Q is placed at each corner of a cube. Point charges Q are placed at each corner of a cube, and question is find force acting at a corner. Find force acting at a corner. Take size of the cube or side of the cube is A. Let me draw this cube. Say this is cube of side A. Question says point charges Q are placed each of its corner charges Q are placed. Now we want force acting at any corner. Again, by my trick, Let us say we want to write the force acting on this point charge q. Better this take this as a origin, take this as a x-axis, take this as a y-axis, and take this as a z-axis. So this is a cube of side A. This is x-axis, y-axis, and this is z-axis. Write down the coordinates of each charge. I'm starting from this. The coordinate of this point charge will be A0, 0. Then force will come out to be 1 over 4 pi of epsilon naught. Okay, this will be q square. And one more thing, this q all of the same sign, so repulsive force minus q square. What will be the vector, a line joining from origin to this point? It will be, that vector would be, it's a ai cap, so its magnitude will be only a, its direction will be vector upon its modulus, which comes out to be I cap. It's a I cap. I use negative sign because the force is repulsive. Now, take this charge. Coordinate would be A0. So, again repulsive, Q square. This vector would be AI cap plus AJ cap. AI cap plus AJ cap, which magnitude would be A root 2. A root 2, okay? And unit vector would be AI cap plus AJ cap upon A root 2. The same way, write down the coordinate of this point 0, A, 0. So what would be the force? It would be, it's again repulsive force minus q square upon a square. It would be aj upon a, that is minus j cap. Now take this point, this coordinate would be, it's 0 a. See, it's a 0 a. Okay, so repulsive force minus q square upon a root 2, it's a aj cap plus ak cap upon a root 2. Of course, this is distance square. Now take this point, it would be 0, 0 a, that is repulsive force minus q square upon a square comes out to be only minus k cap. Take this point, it would be, it's a 0 a, a0a. So it's minus q square upon a root 2, because it's a ai cap plus ak cap. Its magnitude will come out to be a root 2. The unit vector would be ai plus ak cap upon a root 2. Now the last one, this, the coordinate would be a. So here it's a repulsive force, and a, the vector would be ai cap plus aj cap plus ak cap, okay, which unit vector would, which magnitude would be a root 3 whole square. The unit vector would be ai plus aj plus ak cap upon a root 3. So you can see this is a difficult question, but I have solved in just on one line. What you have to do is place the charge first, place the charge at origin on which you want to find force, then define axis x, y, z, then write coordinate of each point carefully, okay, and then if the force is repulsive, as you can see each charge was positive, so the all forces will come out to be the repulsive, so that is why I put negative everywhere, okay. So If the force is repulsive, use negative sign. If the force is attractive, use positive sign. You can see, you can write this force, total force, in one line. So this is a difficult most question, but I have solved just in one line for you. Now the next thing will be, you can write the force in something, it will come out. Collect the coefficient of I cap, J cap, and K cap. If you want to find the magnitude of this force, it will be the under root of coefficient of I cap ka square, coefficient of J cap square, and coefficient of K cap square. That will be your answer.